Hello, everyone. Today is the final day of our challenge 30 days, 30 machine learning projects. Um, the problem of the day, which is 30, is that we have to predict loan approvals using ensemble learnings. For example, random forest and XGBoost. So, why we are doing this challenge, or why we are thinking of finishing the challenge with this problem? Because we wanted to solve an advanced problem. If you remember, we have solved individual problems on these uh, models like SGBoost and random forest. Today we are going to solve the problem with both of them. And yes, so let's get started. I'll go in. Before starting, I'll say it again. The flow of the problem is going to be similar to the last 29 problems. We will take the help from ChatGPT for everything, for from code to explaining the concepts, everything. So let's get started. I'll say copy it and then go here. Let's move this thing here and say, hey everyone. Sorry, hey. Today is day 29, day 30 of the challenge, and the problem is this. I'm sorry you may hear me sneezing because I'm not well. I got fever last night, but I'm really excited to solve this challenge, as in complete this challenge today. So, like all our previous problems, we will be first loading the data. We can load the data and get the data sets from this problem from Kaggle. Once we load it, and then we will have to pre-process. If you notice, we have been doing pre-processing by handling the missing values. We apply encoding if there are any categorical data, using one hot encoding, and there was one more. And then if required, we apply the scaling also. So then we extract the features and target, and then we train the model. Then we are going to train both the models and then going to evaluate and then compare the result. So it is going to be very straightforward problem today, considering we have already put a lot of efforts understanding about all these models and all these terminologies in this challenge in these 30 days. So let's get started. I'll go create the file for today's problem called day 30.py. I'll add it to my Git repository. I'll mention what the problem is about. The problem is about this, and the data set. Where should I get the data set from? As we saw, we can get this data set from which problem? We can get this data set from this problem from Kaggle. So let me go get the data set. It has 12 columns. How many? Let me go here. Loan approval prediction data set. Loan prediction data set. I don't know if that is the same. We'll go and load prediction. I guess this is. I'll go come here. It says that this is from the financial records and associated information to determine the eligibility of individual organization for obtaining loans from a lending institute. So it has 13 columns, and the last column it shows 13 columns. How many columns it has? Loan ID and everything. uh, Commercial asset. Hmm. Yes. So we need to predict loan approval, right? I guess I will go ahead with this data set. So I'll go and copy and mention this data set we are using. Okay. And let's go and download this data set. Yes, let me download this data set directly, uh, because usually from here it will download the zip, and it is downloaded. So I'll go do what, I'll move that dataset from the downloads folder to our dataset folder. So it is going to be from downloads, which loan approval dataset to our folder. And yes, I'm not going to push all this dataset to the git repository because I want to keep the originality, as in where I have got this set. I do not want to claim it as my own. So I do mention where I'm getting it from, or from my tech journal also. This website you can get all information from where I have got the data set for all the problems. So I do recommend you to go and check out. So with all the blabbering, let's get started. So we'll import pandas because it is easier to manipulate the data with pandas data frame. Once done, we will do what? We will load the data from this function read csv, mention the location, and here the file. We will see how the data looks, how many columns it has, and everything, what is the data type of those columns. And then we will also print some rows from this data set using what head function of this data frame. Then we are going to simply run this file, call day 30, not here, here, day 30.py. Once done, I should be able to see that it has these many columns. We see that it has 12 columns. This is the loan status. I feel this is going to be the target for our problem, whether the loan can be approved or not. And these are the things that we may use for as our feature to train the model. This is a regression type problem, right? Because we are predicting, no, this is a classification type problem where we are predicting whether the loan is going to be approved or rejected. So this is a classification type problem. And yes, we will, this is going to be the step 1. I'll comment it. And this is step number 1, load the data. Okay. And then the step number 2 is pre-process the data. And what are we doing going to do? We need to see if the data has any null value. So how we will do, we will print it. We will print it using is null and see how many null values it has. So I'll go run this, and here I'm not calling on object, right? It is a function. So I see we do not have any null value. So what we are doing, what we were doing here, check for missing values, and we do not have any missing values. Okay, then we will do what, comment it. And then because we have seen it, now next thing we are going to do what, we, if you remember, we saw how many columns we had. Here we see this is an object type column. This is an object type feature. This is also an object type feature. So what we need to do, we need to separate first this. And what we need to do, we need to convert this into, we have to convert this textual data or categorical data into what, into, so let's say, into numerical, so that our machine learning algorithm can understand, right, can be trained on that numerical data. So what are the type of values it has? So if I say print data what education, if I say here it is going to be education and unique, we will want to see how many type of values the this column has, and how many type of values this column has. So let's print it, and let's print the loan status also, though we are not going to encode it, convert it into numerical. Why? Because, are we going to? No, right? Why? Because we are not going to use it for training, right? And see how many unique values it has. Let's go run the code again. Not here. Let's go to the terminal, run this file again. It says it does not have a column like education, loan. Hmm. Let's say here, right? Yesterday we did something like that. Hmm? Hmm. Uh, uh, so I'll ask ChatGPT. Here I want to see all the values, unique values of education column feature. What am I doing wrong? Okay, I'm doing correct here. See, everything was smaller caps only, right? I guess it has a space. It has a space. It has a space. Because why I do see a space here, right? See, I do see a space here. Maybe that's the problem. I was right, but I the column name I was using was incorrect. So we have two type of education: graduate and not graduate. Then we have two type of self employed values: no and yes. Then we have two type of values: approved and rejected. The data is very bad. Why does it have? I don't know why it has this extra space. Okay, so what I'll do, so I'll go and mention it that we have this, and then we have this, and then we have this. Okay, and we have got this. So now what we see, these are all classes, a categorical data, right? So what we need to do, we need to convert it into numerical form. And how are we going to do that? We use one hot encoding. So convert the categorical data into numeric numeric using one hot encoding. And here what we are doing, find the categorical data. So here we have found the categorical data. And how are we going to do that? We will do that using what? Using pandas get dummies function. Here we will specify the data. Here we will specify the list of all the categorical features. And then we are going to have this, and then we will have this. I will not go and correct the data now. And do what? I'll mention, do we need to keep the original columns? No. No. So we will say yes. Drop first. Let me go back to the step number 2 only. Drop first true. Yes. Just drop the original columns. And now we will see the data dot info, how it looks, how many columns it has, and then we see the couple of rows using head function. Let's run our file again. Now we see that we do have how many columns we have now. So we have education, not graduate, education. Hang on. Self-employed, yes. Loan status rejected. Why we do not have the list of, yes. Huh. Let me, I guess this is talking about a different data, but I can get this thing work. I want to see how many columns it has. Loan. I want to do what? Replace, refactor. No. Oh, hang on. I went to the, yes, this is the column, right? So I guess I have downloaded a different column, a different data set. Let me go and find the data set here. I'll go ahead and use this one only. Yeah, we are on the day 30th. I think I'm confident enough to pull this off on my own. So, what are we doing? What error we are seeing? I see only three values. I do not see. So, what I'm going to do? My data. So, I'll say my data. What I'm going to do before this? The data set has an extra. So, before this, has extra space before the actual value. Let's remove it. How we are going to do? We will do what? We will do what? Use on our education. This will become new education, and we will apply this space education, the old column. Apply the how many values it had? It had graduate. Space graduate will be replaced with graduate, and space not graduate will replace with not graduate. Okay, and then let's see how many columns we have now. We are not, I have commented the code for encoding. I want to see. Apply in place. Let me go. I'll try one more time. What am I doing? I just don't know. I'll say. So I'm doing this. I'm just a little clueless about the syntax. So I'll go. I'll say, is it correct? Okay. Apply function does not work the way you have used. Instead, you should use the replace method. Okay. Okay. So we should have used replace method. Let's go and run this code again. Okay. Now we should have a column called education. Okay, yes, we have the education column. And now we'll do what? Drop. And then we will do the same for our other three things. Self-employed. Self-employed will be replaced with that. Here employed values were no, will be replaced with no. Yes will be replaced with yes. I'll remove it. And now we will do it on loan status. Loan status. Space approved will be replaced with space approved. Space rejected will be replaced with rejected. Now we will have three extra columns. Run this file again. We should see now. Earlier we had 12 columns. Now we have how many columns? Three more columns. Now we'll go what? First of all, I don't like this cluttering of files. And then we should go and remove the original faulty columns. So data drop this space education and access column, and we have to do same thing with our self-employed and loan status. And now see, let's see, we should be back with our 12 problems. Or we can use this function, or what we can do, we can strip it, right? So what we would have done here, we would have strip it. Let's see if that is working fine. uh, uh, let's run it. Yes. The column name also has space. How do I rectify it? Trailing space, right? Okay, so data columns dot strip space. We don't have to do that. Handle it. Let's remove it only, right? So update the column colum name as well. So how we are going to do that? With data dot columns will be data dot columns dot string dot strip, and then we should be able to see only 12, 16 columns. Okay, let's apply before this. column name first. Now the values. Okay, so we will do what? Remove it, remove it, remove it, and run it. We should have 13 column. We have 13 columns. Okay. Here loan id number of, now we have all the columns without space. Okay, great, this is better. We were earlier handling only the string object type columns, but all the other columns were also having extra space in starting, right? So what are we going to do? I need to see if uh you know what, if the other columns also have extra space. Let's say I want to see if this also has extra space. So I'll see what unique print. I'll comment it and run the file, and it has 20. Yes, I guess that is fine. Is it fine? Paste with them, replace with them. Yes. Hmm. Yes, now we are, I guess, really done with perfecting our data. Now we'll do what? We will update. We will do what? We will apply hot encoding on these two columns only. And now let's see how the data looks like. Let's go back here to the step number 2. Oh, here we need to say this column. Okay, we have how many columns we have? So it removed two columns and replaced it with four columns. So earlier we had how many? How many columns we had? Now it has education not graduate, self-employed. Yes, we do not have the value of the other two fields, right? Oh, okay. So if it is self-employed, yes, it is going to be true. Otherwise, false. Okay, makes sense. Makes sense. So yes, it has applied the one hot encoding here. But I do have a question. So it has created I and I'll ask what question I have. This is how I have applied one hot encoding. I wonder, and uh, and I see two columns. Why does it not have columns for self-employed? No, and self this graduate. This is the output. This is the output of some rows. I'll go copy it. I'll ask. Maybe what I'm thinking is correct. That is, Here also it says if it is false, it is of course that it is not self, it is self-employed. If it is self-employed, yes, is false that it is not self-employed, right? Trapped by dropping one of the categories. Okay, so it is used to avoid dropping. Yes. Okay, so it drops the first category. Okay. If it has two categories, graduate, non-graduate, since you use drop to first, it only creates a column for this, and implicating graduate is represented by the absence of not graduate. Okay, and self-employed is indicated by the absence of this. Makes sense, makes sense. Let me do and let me try this with false, and this will drop the first category. Now I should have four new columns: graduate, education graduate, no, and this and no. Okay, so it makes sense. Which one is better? Drop first false or true? I'm simply going to say which one is better. Achha, it depends on the context of the problem. Okay, for keeping all the categories, this is going to be helpful for the models like random forest, decision tree, or the boosting, because these are tree based models, so it needs to have the true false, right? When using models like, okay, this is better for this thing. These model can handle having all categories without a performance issue. Can be beneficial as it gives them more. Yes, it gives them more flexibility. Yes, so we are going to go ahead with keeping all the columns. So this is how it is going to look. We can see now we will go and create features. Let's go back to the steps. We have converted, applied one hot encoding. Now create features and target data set. So we'll do, this is going to be our feature. Everything except what the loan status is going to be the features. Drop the loan status and drop the columns, and then this is not here, this is going to be our target. Okay, this is feature, this is target data set, data set. Now let's go come back here. It says we need to have two spaces. Yes, let's come back here and go to the step number 3. Split the data into data sets into training and validation data sets. We will go with the ideal 80-20 ratio. Training will have 80%, and the for validation we will have the unseen data, we will have 20%. So let's do that. X train will represent the X for training data, validation X validation will represent the validation feature. Y train will represent the validation. So training target, Y validation is going to represent the data set for the validation. We will use, first we need to import it. So we are going to import from sklearn dot model selection, import train test split. Here we will use this function, specify the target and the feature list, and specify what is the size of our validation dataset, 20%. And random state, yes, to make sure whenever we are running this code it produces the same output. Now we will go to step number 4 and do what? Build and train the random forest random forest model. To revise again, random forest looks like this. It builds the ensemble that builds multiple decision trees and aggregate their prediction to improve the accuracy and reduce overfitting. It builds multiple decision trees and aggregates their result prediction. Whereas the XGBoot, called extreme gradient boosting, also builds multiple decision trees, but the difference is it learns from its mistake. Uh, so how does it learns? It makes sure that it is decreasing the gradient metrics, as in it is decreasing the loss. And I'll go here and see, in on day 15 we first implemented, day 19 we first implemented with this thing. And it says we use for task leveraging powerful gradient will aim to achieve high performance. And yes, here we see that, yeah, just give me a second, I have this headache. Yes, so that it also builds, can you please explain about random forest and exhibit a little in short snippet? Yeah, so we will also revise it. Yes, see, so it random forest creates multiple decision trees on different subset of the data, and each tree gives a prediction. The final prediction is based on the majority vote. This is the random forest. So we will have, this is going to be at this, we will have this. So it creates multiple decision tree, and the final prediction comes out of the majority vote, or the average of all the trees prediction. Whereas xg boot is the extreme. This is the models. We will go with random forest model. Okay, and then next we will take XGBoost, which is extreme gradient boosting. It uses gradient descent to calculate the, yeah, it is it is powerful and efficient implementation of gradient boosting and assemble technique to build these decision trees sequentially. So how it works? It adds trees one by one, and it does what? Each tree attempting to minimize the errors by the previous tree using a gradient descent approach. Yeah, descent approach. It uses boosting technique to improve the performance. Yes. So what this is what I was saying, right? It means that I remember. Feeling happy. So yes, it also builds multiple decision trees, but the difference here is that each tree that it builds on the by correcting the mistake from the previous tree. Using what? Using gradient descent approach. So yes, we will first build the model. Model what? Model random forest, and we will do what? Use random first. For first that we need to import this, right? sklearn.ensemble import random forest classifier, and yes, and then we also have to import xg, not from here, from which library was it? Import XGBoost as, I'll just say XGBoot. I want to see what library did we use. Yes, exactly. From XGBoot import XGBoot X XGBoost classifier. Yes, we want these two. So first we are going to do what? Create random forest, build our random forest model. Here we say how many trees we want, 100 trees we want, and we want to maintain the randomness also so that it produces the same output. Now we will train the model on our X train and on Y against Y train, and then we will have our model. Which model? XGBoost, and we will use XGBoost classifier. Here also we will say how many estimators we want. We want 100 estimators exactly. Let's go back, revise the memory. Yes, and here we need to tell about two other things as well. That is, we need to talk about, so it is doing it in a different way, but I'll say we will go ahead with using going ahead with this way only. Use label encoder. Yes, evaluation matrix log loss. We need to evaluate the error, right, so that it can perform better. So we say the learning rate is going to be, I'll say how many. So it has, then we need to have learning rate is going to be 1.1, and then we will say random state is going to be 42, and then we will fit it. Why am I not able to run it, right? It's, I did import, right? Fit on X train, Y train. It should work, right? It should work. Which problem is it? Day 19. Let me go and open the code for day 19. Am I doing something differently? Let me minimize it a little. And estimators. And estimators. Learning rate. A random sheet. Correct only. I'll go with it. Now we will do what? Step number 5 is going to be make prediction and evaluate. So evaluate. So we will do what? First we will do for random forest. So we will do for random forest first prediction for random forest, and we will use model, not this one, random forest predict on X validation, and we will do what? We will use some metrics to evaluate the model, and we will import metrics from sklearn dot sklearn dot metrics, import accuracy score, confusion matrix, and classification report. Now we will go and use this metrics to evaluate the performance of the model. So the accuracy score of this random forest is going to be uh, score of the prediction from this model and the actual values. And let's do this same thing for what? Confusion matrix, classification report. Let's replace it with this. Let's replace it with this so that we do not have to write things again. Let's print accuracy score is accuracy score, and we will do what? Print random forest. Okay, so now we will have the same thing for our confusion matrix. Then we have classification, report. Let's replace their exact variables and now do what the same thing for XGBoost. And we will do what? Loop prediction of XGBoost and model which XGBoost predict. I'm definitely doing some mistake here. But let's go with the flow and then see if we are making mistake. We'll go and correct it. And then we will use it, not right, save some time. Here we specify we are going ahead with this. We want this prediction against the XGB boost and the actual values. Let's replace this RF with XGB. This is XGB and replace. And now we have built GB boost. Now we have done what? Classification. We have a typo. We have done what? We have created pre uh, pre predictions. We have a mistake here. Predictions, a typo here as well. So now we have built the the matrix variable as well. We have printed them. Now together, let's do what? Visualize. Step number 6 and run it together. Visualize. So for that visualization, for that what we are going to do? We are going to go back here. I and import the library. Today, you know how this challenge is helping us, or at least me, the ones who are solving it together, following the videos, that we do not need the chat gpt that much as we did on the very first day, right? So we now know which libraries to import, which function to use. See, so yes, that's the power of learn by doing. So from we have to import matplot.py plot libraries as plt. Then we have to import the seaborn as sns because we will be building the heat map. First we will do what? We will use build a figure of size uh, 7 is to 5. Small one will be enough because we have only two classes, approved or rejected. And then we are going to build the heat map. Here we are going to have first confusion matrix. Annotation, yes, we want. The format will have g. Let's go back. Let's go here. How do I visualize them? Using heat map. Why I'm doing that? Because it will save my time to write that code. Now we'll have the title for the x is going to be 0 1, 0 is going to be rejected. So first we'll have rejected. So I'll copy it this, and then we'll have what? Approved, right? And the y tick tables will have similar. And right, these two values were only there, right? If we go approved and rejected, so first we'll have approve and then we will have rejected. Right now, sorted. We did not have the column. So the color, this color is going to be blues. I'll finish it with green. Green is my favorite color. I say approved rejected. Here it should be opposite. Yes, first it should be 0, then 1. 0 is approved rejected. Yes. And here then we mention the, I'll go and check it if that is correct or not. Blues, and then we will say what the X label is going to be, predicted values. The Y label is going to be actual values, and the title is going to be random forest confusion matrix. And then we will have this same, plot it for what XGBoost confusion matrix. Here we are using confusion matrix of XGBoost. Here we did not have space. I'm simply going to, how do we know the order in order of classes in this? How do we figure out the order of classes? To the way the classes are encoded in the confusion matrix generated in the order that the labels are encoded. To determine the exact order, highest, we need to see how to find the exact order. What we can do, we can see, check the unique values in the target values. If it outputs something like 10, the order is reserved. You would adjust the labels accordingly. Okay, correct. So what we did, we have done it when we applied the this. Let's go back again. When we applied to see the unique values of our loan status, we saw the approved first and rejected later. So here we are going to do what? Approved first, 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 and rejected later. Rejected. So the order is how they appear in the data set, and we get that from the unique, this function, and we did that, right? We did that. We saw it how it appeared in our data set using the unique function. So we will go what now, just show it. uh, we are almost done. Clear it and run the model, run the file. And we have the problems. What? Invalid class inferred from the unique values of y. Oh, expected 0 and 1. Let's do what? Let's update our this. So it has expected 0 1. We are passing as approved rejected. So let's do what? Let's convert those values first before creating the features. So in the step 2, we created the feature right here. So what are we going to do? Here we are doing what? For consistency, model expects in 0 1, uh, change z- uh, rejected as reject as 0, and accepted approved as 1, approved as 1. So we'll do what? Data, this loan status will have data, this loan status replace this approved loan status, approved with approved with one. Let's say approved with one.